In the previous section, we have discussed about signal flow graph, what you mean by signal flow graph, and various terms used in the signal flow graph. And in this session, we will discuss about construction of signal flow graph. Okay, so constructing signal flow graph for control systems. A control system can be represented diagrammatically by signal flow graph. The differential equations governing the system are used to construct the signal flow graph. The following procedure can be used to construct the signal flow graph of a system. Usually we know that for drawing the block diagram for a system, first of all we are first of all what we are doing is we will write the differential equation. Okay. Similarly, in the case of signal graph also, we will first write the differential equation. Okay. Then we will take the Laplace transform of the differential equation governing the system in order to convert them to algebraic equations in S domain. And in the next step, the constants and variables of the S domain equations are identified. And from the working knowledge of the system, the variables are identified as input, output and intermediate variables. So, if we want to construct a signal flow graph of the system, first of all we should have a concept about the system and what will be the inputs and what will be the outputs. So, from the working knowledge of the system, the variables are identified as input, output and intermediate variables. And for each variable, a node is assigned in signal flow graph and constants are assigned as the gain or transmittance of the branches connecting the nodes. Okay, we know that in the signal flow graph there are nodes and branches, and branches will contain arrow mark, and we will represent the gain above the arrow mark. And so in the system there will be input and output, and the input and output are represented by the nodes, and the gain is represented, the constants in the equation, S domain equation represents the gain. Okay, and for each equations a signal flow graph is drawn, and then they are interconnected to give overall signal flow graph of the system. So we can construct a signal flow graph of the control systems from the differential equations. Okay, the steps are similar as that in the case of a block diagram construction. Okay, so instead of drawing the block diagram, we are drawing signal flow graph, and first of all we have to identify input, output and constants. By using the input, output and constants, we can draw the entire signal flow graph of graph, and we can combine all the signal flow graph in order to get the signal flow graph of overall system. And sometimes we may be giving the we may be given by the block diagram, and we are asked to change the block diagram to signal flow graph, and it will be an easier procedure once we are given by the block diagram, and we can easily convert the block diagram into signal flow graph. Okay, so for that we have to assume nodes at input, output, at every summing point, at every branch point, and in between cascaded blocks. So first of all we have to identify the nodes. Usually input, output, summing point, branch point, and in between the cascade blocks, etc., we will assume nodes. Okay, so in the block diagram there will be input, output and variables, etc., summing point will be there. So for each of that components we will assume a node. And next step is draw the nodes separately as small circles and number the circles in order 1, 2, 3, etc. Okay, first of all we will draw the node, and the nodes are represented by circles, and then we will represent the number of nodes. That is for identification purpose, we are numbering it. And from the block diagram, find the gain between each node in the main forward path and connect all the corresponding circles by straight line and mark the gain between the nodes. So in the next step we will connect the nodes, and we will put an arrow mark, and we should mark the gain, and that gain will be obtained from the block diagram itself. So the forward path gain will be identified, and that gain will be given in between the nodes. Okay, next draw the feed forward path between various nodes and mark the gain of feed forward path along with the sign. Sometimes the gain may be positive or negative. If there is a negative feedback path, the gain will be negative. So we have to mark that sign also. And draw the next step is draw the feedback path between various nodes and mark the gain of the feedback path along with the sign. Okay, that's all the steps. that's all the steps for converting the block diagram into signal flow graph. It is an easy procedure. Sometimes you are asked to draw the signal flow graph without giving a block diagram, then you have to derive the differential equation and you have to convert it into Laplace transform form, and then you have to identify input and output variables, and you can draw the signal flow graph, and you can finally combine all the signal flow graph to get the signal flow graph for entire system. That is the procedure. Okay.